The Younger Dryas was a dramatic and sudden return to Ice Age conditions that occurred near the end of the last glacial period, roughly 12,900 to 11,700 years ago. It is one of the most abrupt climate events in Earth's recent history. After a long warming trend that was melting the great ice sheets of the Northern Hemisphere, the climate unexpectedly plunged back into cold, dry, glacial-like conditions. Temperatures in parts of the Northern Hemisphere dropped rapidly within just a decade or so. This cooling event lasted about 1,200 years, interrupting the transition toward the warmer, more stable climate that would define the Holocene. While the Younger Dryas hit the North Atlantic region hardest, its fingerprints appeared around the world. In South America, rainfall patterns shifted. In Asia, monsoons weakened. Some parts of Africa became more arid, while others saw unexpected bursts of moisture. And yet, amid this upheaval, life endured. Cultures adapted. Ecosystems reshaped themselves. The planet entered one of the most dynamic periods in its recent history. For tens of thousands of years, a colossal mantle of ice dominated North America. This was the Laurentide Ice Sheet, a frozen empire that reshaped an entire continent. At its height during the last glacial maximum, roughly 26,000 years ago, the Laurentide Ice Sheet covered most of present-day Canada and extended deep into the northern United States. From the Arctic to the Great Lakes, from the Atlantic coast to the Rocky Mountains' eastern foothills, the land lay buried beneath ice up to 3 kilometers thick. The sheer weight of this ice pressed the Earth's crust downward, warping the surface of the continent itself. The ice sheet was not static. It flowed outward from high domes near Hudson Bay, advancing and retreating in slow, relentless motion. As it moved, it scraped bedrock clean, carved valleys and pulverized stone into fine sediment. Mountains were worn down, forests erased, and rivers redirected. Massive boulders were carried hundreds of kilometers before being dropped far from their place of origin, leaving behind the glacial scars still visible today. As the global climate began to warm, the Laurentide Ice Sheet entered a dramatic period of collapse. Meltwater pooled along its margins, forming enormous glacial lakes, among them Lake Agassiz, one of the largest freshwater bodies ever to exist. At the edge of a melting world, a vast inland sea was born. This was Lake Agassiz, one of the greatest lakes ever to exist on Earth. As the Laurentide Ice Sheet began its slow retreat near the end of the last ice age, meltwater pooled along its southern margin. Trapped between the towering wall of ice to the north and higher land to the south, the water spread outward, growing year by year. What emerged was a lake of unimaginable scale, covering parts of what are now Manitoba, Ontario, Saskatchewan, North Dakota, Minnesota, and beyond. Lake Agassiz was larger than all of today's Great Lakes combined. Its shoreline shifted constantly as the ice advanced and retreated, leaving behind a stair-step pattern of ancient beaches etched into the landscape. Along these shores, waves crashed against ice cliffs, and cold winds swept across open water where tundra and boreal forest would one day grow. But Lake Agassiz was never stable. It was a lake held back by ice, temporary, fragile, and dangerous. As the Laurentide Ice Sheet thinned and fractured, its icy dams failed again and again. When they did, vast torrents of freshwater were released in catastrophic floods, racing across the continent through newly formed river valleys and spilling into the North Atlantic and Arctic Oceans. At some point, whether caused by a gradual overflow or the sudden collapse of an icy barrier, the waters of Lake Agassiz surged outward in a catastrophic flood. Trillions of gallons of cold, fresh meltwater raced northward into the Arctic or eastward into the North Atlantic. It was not a slow leak. It was a torrent, one of the largest freshwater floods in Earth's recent history. This freshwater was lighter and less salty than seawater. It spread across the North Atlantic, disrupting the engine that drives the deep ocean currents. Without the steady flow of warm water to northern latitudes, temperatures dropped sharply. Under normal conditions, warm, salty water flows north across the Atlantic, cools, sinks, and returns south in deep currents. This constant movement carries heat toward Europe, shaping climates on a global scale. But when the meltwater pulse diluted the ocean's salinity, that sinking motion slowed, then faltered, and in some regions may have stopped entirely. Without the northward flow of heat, temperatures across Europe and the Levant plummeted. Storms grew fiercer. Rainfall patterns collapsed. Within a human lifetime, the world that had been warming spiraled back into an icy grip. This was the Younger Dryas, a 1,000-year winter born from a single pulse of water. The effects were immediate and profound. Glaciers halted their retreat. Some even grew again. In Europe, forests died back, replaced by windswept tundra and cold steppe. Across the Levant, rainfall collapsed. Rivers shrank, grasslands withered, dust storms increased as the land dried. Animals adapted to warmer climates withdrew or vanished from the region. Reindeer, wild cattle, gazelles, and other species shifted their ranges, responding to the returning cold. Human cultures felt the impact immediately. In the eastern Mediterranean, the Natufians flourished just before the Younger Dryas, one of the earliest cultures to build semi-permanent villages, relying on abundant wild cereals and gazelle herds. But as the climate turned colder and the region plunged into drought, everything shifted. Grasslands withered. Seeds grew scarce. Gazelle populations scattered into wider, unpredictable ranges. Villages once filled with stone huts were abandoned. Some families returned to a nomadic life, following whatever food remained. Others stayed, experimenting with tending wild plants, small steps that would eventually help lead to agriculture. For the people of the Levant, the Younger Dryas was not just a cold spell. It was a cultural turning point. Across Europe, the warming world had been ushering in birch and pine forests. But when the Younger Dryas struck, those forests died back almost overnight. Tundra reclaimed the continent. Reindeer, horses, and mammoths moved across the frigid plains once again, and human groups followed them. Hunter-gatherer bands that had begun to settle more frequently were pushed back into highly mobile lifeways. Cold winds, sparse vegetation, and shifting animal migrations forced people to travel farther, hunt harder, and endure conditions their ancestors had hoped were behind them. In Europe, the Younger Dryas meant survival on the edge of ice. In North America, enormous changes were already underway. The Great Ice Sheet still covered much of Canada, but the warming had opened new corridors and landscapes for the first time in millennia. When the Younger Dryas hit, glacial retreat slowed or reversed. Cold, dry winds scoured the plains. Large mammals, such as mammoths, mastodons, and giant bison, faced new environmental pressures just as human hunters were spreading across the continent. While the reasons for megafaunal extinctions are complex, the Younger Dryas added a final layer of stress to animals and people alike. In North America, it reshaped ecosystems and the lives of the early populations moving through them. Across Asia, the Younger Dryas disrupted rainfall patterns on a continental scale. Monsoons weakened. Grasslands across Central Asia dried. Rivers shrank in China and western Siberia. Hunter-gatherer groups adjusted by following the narrow bands of land where water still flowed. Valleys, river corridors, coastal zones. These pressures may have contributed to pulses of migration, sending people into new territories and reshaping the human map of Asia. For many communities, the Younger Dryas meant chasing stability across a landscape that no longer behaved predictably. Far from the North Atlantic, the impact of the Younger Dryas varied. Some regions of Africa saw increased drought, while others became unexpectedly wetter as global climate patterns shifted. In South America, rainfall reorganized, transforming river systems and altering the distribution of tropical forests and grasslands. People adapted with remarkable flexibility, changing hunting territories, exploiting new plants, and moving in tune with the reshaped ecosystems. The end of the Younger Dryas, around 11,700 years ago, was one of the most abrupt and consequential climate transitions in human history. After more than 1,000 years of bitter cold, the climate shifted with startling speed. Temperatures in the North Atlantic region rose sharply, by several degrees within just a few decades, and in some places perhaps within a single human lifetime. Glaciers that had stalled or advanced during the Younger Dryas began to retreat rapidly. Snowlines climbed higher into the mountains, sea ice withdrew northward, and seasonal rhythms stabilized once again. This warming appears to have been triggered by a reorganization of ocean circulation, especially the revival of the Atlantic meridional overturning circulation. As massive meltwater discharges diminished or were rerouted, salty, dense waters once again sank in the North Atlantic, restoring heat transport from the tropics to the Northern Hemisphere. The climate system snapped back into a warmer mode, marking the formal beginning of the Holocene epoch. The environmental transformation was swift and widespread. Tundra and steppe gave way to expanding forests across Europe and parts of the Near East. Rivers became more reliable, lakes refilled, and rainfall patterns grew more predictable. In the Levant, wild cereals such as wheat and barley rebounded, oak and pistachio woodlands expanded, and animal populations recovered. For human societies, the end of the Younger Dryas was a turning point. Communities that had endured scarcity, drought, and mobility during the cold phase now found themselves in a more stable world. In the Near East, Natufian groups re-established permanent settlements, intensified plant gathering, and soon began experimenting with cultivation. Within a few centuries, this climatic stability helped set the stage for the Neolithic Revolution, the rise of agriculture, villages, and eventually complex societies. In essence, the end of the Younger Dryas was not just a return to warmth. It was a sudden release from climatic stress, a moment when Earth's systems settled into the relatively stable conditions that it would support human civilization for the next 12,000 years. The Younger Dryas stands as one of the most dramatic climate events in human history, a global reminder of how finely balanced Earth's systems are. Its sudden onset, long duration, and rapid ending shaped landscapes, ecosystems, and human societies in ways that echoed through the millennia. Today, scientists study the Younger Dryas, not only to understand the past, but to learn how sudden climate changes can ripple across the planet. In the story of our world, it marks the moment when nature reminded us of its power. A world paused on the edge of warmth, dragged once more into the cold, and finally released into the dawn of the age we call home.